All right. So back in integrated 2, you learned these three trig ratios. So I'll just remind you real quick how they work. So this angle right here is your reference angle. So from this reference angle, this side length is opposite, this side length is adjacent, and this side length is the hypotenuse. Your sine ratio is opposite over hypotenuse. Your cosine ratio is adjacent over hypotenuse, and your tangent ratio is opposite over adjacent. So you have those three. Now today we're going to learn three new ones. All right, so those are the three that we already know. So now we are going to look at, we're going to have, for sine, instead of opposite over hypotenuse, we're going to have one that's hypotenuse over opposite. We're going to have one that's hypotenuse over adjacent. And we're going to have one that's adjacent over opposite. All right, the one that goes with sine, so the opposite of sine, is called cosecant. And you say it's CSC, but it's this is short for cosecant. The one that's going to be opposite of cosine, hypotenuse over adjacent, is secant, which is shortened with SEC, so secant. And the opposite of tangent is going to be cotangent. Huge mistake that kids will make is they will flip these two, but that's because you would think that sine goes with secant because they both start with S's, but it's the opposite of what you would think. So cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Make sure you have at least these three written down. I mean, I would write down all six, but make sure you have at least these three. Okay, so now, if we are given this problem, if you are given that the cosine of theta equals 3 over 5, so remember cosine is adjacent over hypotenuse. This looks terrible. It's not. All this is saying is your angle is in between 0 and pi over 2. Pi over 2, where's that at? Well, that's at 90 degrees. So, so you're given this one ratio and it wants you to find the other 5 given this. So if you were to draw your x and y axis, so here's 0, here's pi over 2. So all this thing means is that we're looking in this quadrant. So I'm just going to draw a generic line that goes out. So when you draw your line that goes out, when you make your right triangle always comes down to the x-axis. Or let's say you were in this quadrant. So let's say it tells you to go to this quadrant. You're going to go up. You always go up or down to the x-axis. Okay, ignore that. And then your theta, your reference angle, is always going to be the angle that's closest to the origin. So here's theta. It's never going to be up here. It's never going to be your right angle. It's here. All right, so we know that adjacent over hypotenuse is 3 over 5. So from here, our hypotenuse is 5. Our adjacent is 3. And then we actually need to find this length. And if you use the Pythagorean theorem, you'll end up with 4. I'm not going to show you that work because you should know how to do that. All right, so we have our triangle filled in, and now we just need to fill in these other 5 trig ratios. So sine is opposite over hypotenuse. Let's do this actually. So here's theta. Opposite is 4. Adjacent is 3. Hypotenuse is 5. So sine is O over H. I actually recommend writing these out exactly how I am because it's hard to screw up if you do. Tangent is opposite over adjacent. Cosecant Cosecant goes with sine, so what's the opposite? So that's h over o. Secant goes with cosine, that's 5 over, well, I can write that. Let me do this first. H over a, which is 5 over 3. Cotangent is going to be adjacent over opposite. Okay, so now we can O over H, we have 4 over 5. Cosine's already done. Tangent, we have O over A, so we have 4 over 3. Cosecant, we have H over O, so that's 5 over 4. We did secant, and then cotangent is A over O, which is 3 over 4. So if you are given that the cosine of theta equals 3 over 5, this thing right here is talking about which quadrant it's in. So then you can find your missing side length, and then you can fill in the rest of these. Okay, and then we have one more example. Okay, so this time it's telling us cosecant of theta is negative 6 over 5. And we are in quadrant that's in between 2 pi and 3 pi over 2. So I have to sneeze. Excuse me. Sorry. Okay. So I'm going to start by writing over here. So we have sine of theta, we have cosine of theta, we have tangent theta. Then you have cosecant theta, secant theta, and cotangent theta. So sine is O over H, cosine is A over H, tangent is O over A, cosecant is H over O, secant is H over A, and cotangent is A over O. Okay, so then our theta is in between 3 pi over 2 and 2 pi. So here's 2 pi. Here's 3 pi over 2. So we're looking at this quadrant. So you just draw a line out. And then you connect it to your x-axis, and that's how you make your triangle. So this is your right angle. Reference angle is always by the origin. Okay, so cosecant, remember cosecant is hypotenuse over opposite. So hypotenuse is going to be 6. And our opposite, so that's over here, is going to be 5. So now the biggest thing that you need to look at is this negative sign. So let me show you something really quick. Let's pretend you have a squared plus b squared equals c squared. When you have this, so if you have this right triangle, here's a, here's b, here's c. To find c, you're going to take this number squared plus this number squared. If you square two numbers and add them together, it's always going to be positive. This is always, no matter what, positive. Always. Your hypotenuse is always positive. So when I look up here, this is positive. Always positive. So now when you're looking at this fraction, since this is negative, you know that either the 5 or the 6 have to be negative. So your hypotenuse is always positive. So that means that this 5, I know you're talking about a distance, but we're talking about which quadrant it's in. So that's why this 5 is going to be negative. So you can think about it this way too. This 5 is actually going down the y-axis 5. So if you're going down 5, this would be negative. So then we need to find this length. So I'm going to, we'll go off to the side up here. So we are going to have to find this missing length, use Pythagorean theorem. So it'll be this side squared, so it'll be 36 minus 25 equals, that's what, 11? And then it's the square root of 11. So this length right here is the square root of 11. So now Is this square root of 11 positive or negative? Well, you're on the x-axis and you're going this way, which is positive. So this stays positive. Now let's say you were over in this quadrant. Well, if you were in this quadrant, both of your adjacent and your opposite are going to be negative because you're in the negative quadrant. Okay, so now we need to fill in these. So let's see. So if this is theta, your reference angle, this -5 is opposite, the 6 is your hypotenuse, the 11 is your adjacent. So O over H, opposite over hypotenuse, is going to be -5 over 6. Cosine is A over H, so that's the square root of 11 over 6. O over A is -5 over the square root of 11. Cosecant is H over O, so which is 6 over -5. And then you can always put the negative up front. And if we check our work, oh, well, that was the one they gave us, so we were doing something right. And then secant is going to be H over A, which is 6 over square root of 11, and then O over A is -5 over, which one did I do wrong? Or A over O, I said it wrong. Square root of 11 over -5. So let's look at these answers quick. This one I'm okay with, this one I'm okay with, this one we have to fix. This one looks good, this one we need to fix, this one we need to put the negative out front, so get rid of that. Put the negative out front. You cannot have radicals in your denominator, so you have to rationalize. So we're going to multiply this by square root of 11 over square root of 11. Oh boy. And you get 6 root 11 over 11. And here you're going to get, yikes, -5 root 11 over 11. I skipped it. Okay, so now that we have this down, let's go back to this page. Okay, so if cosecant is H over O, secant is H over A, and cotangent is A over O, this is exactly the same. So I want you to write this down and save this too. Or you can write cosecant of theta equals 1 over sine of theta. Since these two things are opposite, it's the same as 1 over sine, which means secant is the same as 1 over, oops, not secant. Sorry. Secant theta is 1 over cosine theta, and cotangent theta is the same as 1 over tangent theta. Okay, so make sure you have at least this written down.